Picking up where we left off in the last video, talking about sig figs, we're going to talk about how we deal with sig figs and calculations. Now, so we know how to identify what digits in a number are significant, which is to say which ones are conveying precision, which ones are not. And so now when we actually start doing calculations with these numbers, when we actually start using equations and things like that, we need to know how to deal with those, how we can figure out how many significant digits our answer should have when we finish doing a calculation, as an example. So when we're doing these, we kind of have two basic rules. We have rules for addition and subtraction, and we have rules for multiplication and division. So if we're taking two numbers and adding or subtracting them, one from the other, the rule for sig figs is that the answer at the end of that mathematical function will have, it can only have digits to the last common decimal place. So if we had some number, for example, that was 1.002, and then we added to that 3.1, mathematically speaking, that would be 4.102. That's what that would be just from a purely mathematical standpoint. But according to sig figs, because we only knew this number to the tenths place, we have no idea what's going on back here, we can only report our answer to the tenths place. Because we, even though in this number we knew to the thousandths place, we have no idea what's going on even in the hundredths place with this number. And so our answer can only be reported to that last common decimal place, and so it would be 4.1 would be the answer there. Now with these we do round, and we're going to use the standard rounding rules. Apparently some books, and it might even be the book that we're using now, they have new rounding rules. I'm going to refer back to the, if you've seen The Incredibles 2, where it's math is math. Math is math. We're just going to stick with the old rules. Call me old and crotchety, but I'm going to stick to the old rules. So if if you're cutting off a number and the next number, so the very first number that gets cut off, if it is 5 or greater, we're going to round up. If it's less than 5, we're just going to leave the number as is. And so since the very next digit here is less than 5, we're just going to leave it as 4.1. Multiplication and division. If we're doing that in our mathematical function here, then the way that we calculate how many sig figs our answer can have at the end is that the quantity with the fewer digits limits the precision of our results. So if we were multiplying, let's say for example, 2.812 times 6.0, just to give a random example here, and I'm actually going to have to calculate that on my calculator because I don't know what that would be off the top of my head. So according to the calculator, that would be 16.87, oops, ran out of space there. Write that down here, 16.872 would be the calculator answer, which does not take sig figs into account. When we look at our numbers here, this number has 4 sig figs, this one has 2. So because one of our numbers only has 2 sig figs, the multiplication and division rules tell us that our answer can only have 2 sig figs. So we're just going to start at the left, say we can have this digit and we can have this one. Now we are going to round here. So the next digit, the one that gets cut off, the very first one to get cut off, in this case is greater than 5. It is 5 or greater. And so our answer here would be 17. All right, hopefully that makes sense. Here's a few other examples here for you to work through. So I would like you now to pause the video, work through these examples, see if you can figure out what the correct answer is with correct sig figs. Don't just type these into your calculator and write down what it gives you. The calculator does not take sig figs into account. So find the correct answer with correct sig figs. So pause the video now. All right, hopefully you worked that out on your own. So if we type this first one into our calculator, 1.0023 plus 4.383, that will give us 5.3853. That's what the calculator gives us. But if we check the sig figs here, this has 5 sig figs. This one has 4. Because we're adding them, we can only take our answer to the thousands place, because that is as far as this number goes. This one goes to the 10,000ths, but because this one only goes to the thousandths place, we're going to cut this number off here. The next digit is less than 5, and so our final answer is 5.385 grams. Same kind of thing here, 421.23 minus 486. If we do, and actually it's the other way around, sorry. So flip those, essentially. So it's 486 minus 421.23. So 486 minus 421.23. If you do that correctly, you would get 64.77 as your answer. That's grams. But, once again, the last common decimal place is actually the first place there, the ones place, as it's sometimes called. And so we had to cut off the number right here. Since the next digit is 5 or greater, our final answer would be 65 grams. Okay, what about these other two down here? So 0.6238 times 6.6 gives us 4.1, let's see, 4.11708 centimeters squared would be the units on that, since both of them have units of centimeters. But this number has 4 sig figs. That is a leading 0. It is not significant. This number has 2 sig figs. So because we only have 2 here, our answer can only have 2. So you'll have 4.1, and that is actually going to be the entire answer because the next number is less than 5, and so we're just going to leave it at 4.1 centimeters squared. So then the last one here, 421.23 divided by 486. The calculator gives me 0.8667283951 grams per mil. That would be the units because we're dividing grams by mils. Obviously, we cannot keep all of those. These are the same numbers as we had up here. This one had 5 sig figs. This one has 3. And so, because we only have 3 sig figs in this number, that means our answer can only have 3. Remember, this is not significant, this 0 here. So we're not going to count this as our first one. This will be the first number, and then second, and then third. That's as many as we can keep. So then, because we're cutting off the number here, we're going to look at the next number. If it's 5 or greater, we're going to round this one up, and it is. And so our final answer here is 0.867 grams per mil. All right. Hopefully, you all got the same answers as I did. The last topic here is density, and I think we'll go ahead and make this a short video. I know the previous one was really long, so we'll make this a short video, and we'll cut this one off here, and then we'll finish up very briefly with density. Density's not too long in the next video. So I'll see you in that one.